Hi and welcome to MRTV. Today I have a very interesting interview for you. I had the chance to speak with Johan Hellquist, the head of XR of Tobii, the world leader for eye tracking solutions. We're going to find out what eye tracking is, how it works, and why it's so important for the future of XR. So absolutely stay tuned, watch the whole video because all of this goodness is coming up. Welcome back again here to MRTV. My name is Sebastian Ang, and this channel here is all about virtual reality. I'm bringing you independent XR reviews, you're getting the latest news, and I'm bringing you interesting interviews just like this one here. So, if you have not yet subscribed to MRTV yet, why don't you do so now? And without further ado, let's get into the interview now. It is my great pleasure to say hello to Johan Hellquist, who is the head of XR for Tobii eye tracking. Hello, Johan. How are you doing?
Hello, Sebastian. I'm doing awesome.
Awesome. That's great. Thank you so much for your time and greetings from Dortmund to Stockholm in Sweden.
Yeah.
Must be very cold there right now, right?
It's okay, not freezing, but getting there.
Right. Whenever I only went to Sweden in winter. I should come in summer sometime. I heard it's really beautiful there, right?
Midsummer when it's hell, very bright.
Right. Okay, I'm really looking forward to this talk because I want to know everything about eye tracking and what it's going to mean for the future of our favorite hobby and or even like work, VR, and in the future also AR, or probably even now, right now. And I'm sure that you are exactly the right person to tell me. So is it right? Can I say that Tobii is the market leader, the worldwide market leader for eye tracking?
Yeah, that is right. I mean, we've been around for almost 20 years. We are roughly 1,000 employees all over the world, and we live and breathe eye tracking. So we do eye tracking in VR, we do it in PCs, we do it in for medical, we do it for glasses, whatever you want an eye tracker, we do that.
Okay, so where can we find your eye tracking? In which VR and AR headsets could we find it right now?
So when it comes to XR portion of Tobii, which I'm heading up, we have eye tracking in our own devices, which is for scientific use. I will show them soon. We also are in Device Pro Eye, which is one of the first headsets with eye tracking. Been one of the established and standards on how you use eye tracking and how it works. We're also in the standalone device of Pico Neo 2i.
Oh, actually, I have one here, prepared here for our viewers.
Yeah. So the Viper Eye is up here.
Right.
And then we're also in the new one, the gorgeous HP Omnicept, which kind of brings another level of sensor technology into VR world.
Right.
So those are the three official ones that we have been part of.
Okay, that's great. So for all of our viewers who don't know yet about the HP Reverb Omnicept, it's basically a reverb with everything that makes it great, like the high resolution, but it has eye tracking and even like some mouth tracking feature, right? There are some cameras.
They have a mouth camera and they have eye tracking for a kind of tracking where you look, but also your pupil tracking.
Okay.
So they use we use that for combining those sensor data for cognitive load decisions and measurement. So it's a great platform.
Okay, looking forward to find out more later when we talk about what it actually can do. So before we get into all the use cases of eye tracking, probably we would like to know how does it actually work? So your eyes are being tracked, so it can track like exactly where you're looking at. And how would that work in virtual reality or when you wear the glasses?
I can actually start with a VR or RealWear. So you have cameras. Do you see?
Yeah, a bit higher perhaps.
So we have cameras looking towards your eyes.
Can you put it a bit higher? A bit higher. Yes, this is good.
We have cameras that are looking at your eyes, and then we have illuminators around.
Okay.
And we illuminate with near infrared that's not visible for you.
Okay.
And based on the reflected gaze pattern or pattern of your eyes, we calculate where you look.
Okay.
And we also determine where your pupil is, and can kind of based on that decide where you look.
Okay.
So on an Omnicept,
Yes.
like this one,
Yes.
then the cameras are behind the lens.
Behind the lens. Okay.
Behind the lens, and then you have the illumination before.
So, like on the very right and the very left, like looking into the into the lenses, into your eyes, or where are they located? Or,
Yeah, so
or at the nose?
So they are located basically in the middle.
Oh, in the middle. Okay.
Yeah, but they are bouncing via a semi-reflective piece of glass called hot mirror.
Okay.
So you bounce the camera and then back to your eyes. So the camera sits kind of here,
Right.
beneath, and then you bounce the camera view inside behind the lens. You don't see that, so it is as if the camera is just in front of you.
Okay, so this is some kind of like reflective mirror, something like.
Yes,
Okay.
it's a reflective mirror which is kind of half reflective, so it's reflective for near infrared but not for visible light.
Wow, this sounds really cool.
Yeah, so that is the design that we use for HP and also for HTC and for the Pico design as well.
Okay.
So if you take a look, you can see that yourself as well.
Yeah.
So you don't see the camera, but
exactly. So, but I do see. I'm not sure if you can see it. Like these are like. So this is the IR light. This will illuminate my eyes. Okay.
Yes. So based on the pattern, the reflection pattern, we then calculate where you look.
Wow. Okay. That's
really
interesting.
It's pretty straightforward as a starting point.
Yeah.
So I think any AI as savvy engineer can do a basic eye tracker.
Okay.
But it's take tremendous amount of work and experience to do an eye tracker that works for everyone.
All right. So why is it so complicated?
I mean, there's different people, there are different ethnicities, there's different.
Right. Okay.
You need to difference between droopy eyelids. You have mascara. You have eye disease that you need to know when they occur.
Okay.
So just tracking one is not okay. You need to track a full population, and that is the difficult part.
Okay.
So that's where we spend all our time. It's kind of how do we track the most difficult ones.
Well, interesting. And I believe for these kind of VR headsets, which are at this moment in time still kind of bulky, it's okay. There's still some room to put the camera. But how about in the future when our glasses look more like sunglasses? Is it going to be harder to hide it? Oh, yeah, like this. Yeah, exactly. Like this one actually.
So this, right?
Yeah.
So these are products that we have in the market for research.
Okay.
They are a little bit more expensive, but I think the principles are two, that you do not need to have the cameras behind the lens, because as you say, if you don't have space enough to have them behind the lens, or if there is no lens, if it's an AR, you need to have them somewhere else. And then we have them, like in your glasses, we would put them in the rim of your glasses.
Right.
So that's why I want to say we have different eye tracking approaches depending on what kind of end user system it is. So for VR headsets like the HP and HTC, then what we call the hot mirror base, where you have the camera behind the lens, is the most appropriate one. If you have a pancake lens design or collapse, which is coming now, and we see viewers from different companies, then you need to put the cameras and illuminators in front of the lens in that case. And in AR, it's the same.
Okay, interesting. So you're working on all kinds of different solutions already for all the different kind of sizes for whatever will come. You're going to give eye tracking to all these devices.
We follow the trends. And
of course.
I think
that makes sense. Cool. So now that we have a better understanding of how actually it works, how you can actually get the eye position, tell us now about what we can actually do with it. How is it being used right now? What are the applications in games and also in work?
Yeah, so I think we typically categorize the type of usage in three different ones. One is what we call better devices, making the device perform better. I'll get back to that a little bit.
Yeah.
The second one is better experiences, which is kind of more obvious. And the third one is better insights, kind of looking where did the user look. So better devices is one of the most important for us to justify eye tracking and also to move from high-end enterprise to ultimately consumer. So, for example, if the eyes are pretty crappy sensor systems, or they're genius, but you're only sharp and focused in the size of a thumb. The rest is black and white and low resolution. So we use that fact to tell the graphical renderer to only render where you're looking and do that dynamically. We call that dynamic foveated rendering. And that is a way to either decrease the load on your graphic cards or enable more graphics to be utilized on your existing hardware. So by using eye tracking, you will get basically one generation more rendering capacity than you have right now. And then you can use that either to save or to increase. And we think you rather want to increase than save, at least in a headset like the HP Omnicept.
Right, but if it's built into like a standalone headset like the Pico Neo 2, you could also use it to save energy, right?
Exactly. So it's either more or to save capacity. And as a human, we do that to save energy.
Right.
That's why we don't render. The brain doesn't render the full scene for us. We only render where we need it, because it would be such a waste of resources to render or to render full resolution everywhere. Our brain would have been kind of 2 times as big.
Okay, I got it.
So that's one key. The other one is deciding where you have your eyes in the headset. You want them in the middle of the lenses for optimal performance. And how do you know that? So Viper Eye, for example, uses that to kind of say, now you have your headset in the optimal position. You can also use it for if you transfer data from a cloud rendered solution in the future. Just transferring full rendered resolution images is expensive. So then you only render and transfer where you're looking. So those are the kind of device-centric benefits. We also have multifocal display, which has been around, and there you need to understand where the user is looking as well. So from a better device perspective, we think that eye tracking will be basically mandatory for current and current-based use cases, but for future displays. The other is better experiences, we call it. I mean, in these Corona times, remote collaboration. I think your previous show with the HTC guys,
right.
You showed Vive Sync with gaze tracking, or where you animate where you're looking.
Exactly.
To have a more natural way of communication. And other experiences is, well, hands-free navigation is one very important one for enterprise use cases. Another one is just a simple question, what is that? It's very difficult to answer. But if you have gaze, it's very easy to answer.
Okay, right, because you know exactly what you're looking at, right?
Yeah, so it's getting a more natural interaction with the device. As when you and I are communicating, we tend to try to look at one another, at least on the camera, and when you're not, it feels a little bit strange. And the same is with the zombie looks in avatars in VR.
Right.
And then the third, which is one that is most used in enterprise application, is kind of deciding where did I look.
Okay.
So we have, for example, Ovation, who's a company doing training for public speeches. There you can measure, okay, where did I look at the audience, or did I just look on my papers? We have another example which Qualcomm made together with Accenture, making a store, which we do with these live, but then you move into virtual, and then you kind of decide, did I look at the shelf, or did I not look at the shelf?
And at what magazines did you look?
Exactly.
Like, what did you look at there again?
Yeah, no, so and that's kind of is of course extremely powerful, because your eyes are semi-conscious. if you hear a bang somewhere, you immediately look.
Right.
You can't stop yourself. So, and that's the same with when you're doing investigating on human insights. You can control, but at the same time, you're not thinking where you're looking. So that is one very, very powerful to understand human behavior, which is yeah.
That is really interesting. So if I'm a store owner and I know exactly what kind of placement works the best and where do people look at most, okay, then I can just place my items that I really want to sell there where they look at, right?
Yeah.
That's really powerful.
So we have one whole division at Tobii doing only that.
Wow.
So we've been doing that in real world. So doing market insights, and now we see that it's being deployed in VR, where building the shop itself is much, much cheaper.
Mm-hmm.
So we think this will be one of the key use cases that will be a fundamental part of making designs or market research in general. And I think design, where you can try different designs and try them, how people react. You can't do that as efficiently in the real world as you can in the virtual world. So I think there were some great examples in your ViveSync interview with the dragon that was shown. That could be whatever. Yeah. That could be a new headset. It could be a new car. It could be a new Kellogg's Flake package design or whatever. And there we think eye tracking and kind of how people react to a new object will be very, very, very important. Wow. So those are the three kind of main categories of use cases.
Very, very interesting. And just thinking about how we're going to use these AR headsets also in the future, probably we're also going to wear an AR headset when we drive our cars. Could that be to have some kind of information of our driving there?
I mean, the imagination is the limit, right?
Yeah, right.
I mean, AR is. I'm a super strong believer in AR long term. That it will be.
Me too.
Not the replacement of the phone, at least the extended vision arm of your phone, and to connect to your car. That's one item. And there's, I mean, there's no limits to the need, and there I think there's also one of the kind of the foveation technologies. For example, if you are wearing AR, walking around in the real world, and you have some AI machine in the cloud, 5G is connected somewhere, where should they do the processing on? Should they process on everything, or only where you look? We think they should only process where you look.
Yeah, because you're making the eye tracking.
Of course.
Yeah, sure, but it makes sense. Yeah.
I mean, it's like humans, right? You have your eyes, you don't process everything, you only process where you focus.
That makes sense.
So, and that goes back in interaction as well. You do stuff where you have your focus.
Yeah, of course.
You kind of look and then you click, or if you want to in-game, if you want to throw something, for example, how do you know how heavy a stone is in the game? You don't. So, but you know where you want to throw it. That's where you're looking.
Wow.
So you throw towards where you're looking. So that's impossible to do in without eye tracking.
Okay, so really lots of applications. It's pretty incredible. And probably also right now, even we don't think of it. And again, the car example, I think it's already being used, right? For like Tesla, they also look at the eyes of the driver and see if he's like paying attention.
Yeah, right? So drowsiness control,
control.
Eyes on the road. That is a mandatory to get the NCAP 5. That's a mandatory test that you can decide whether you have the road on the eyes on the road or not. Not now, but I think it's in 2025. So that's
lots of interesting applications. So let's get back again to XR, what you were doing.
Yeah.
So how do the developers actually make use of the data? How do you present the data to the developers? Is there like one standard that or do you set the standard and all the other eye tracking solution providers now have to follow it, or how does it actually work?
Yeah, so it's a multifaceted question. First, of course, if we sell into an OEM, it's the OEM who typically has the the interfaces, and typically you either adhere to a mixed reality or Steam VR or what have you. What we have been focusing on is to standardize, starting with the basics part of eye tracking. Where am I looking? So we've done that together with Microsoft for remote system, like for PC system, which has been standardized, and we have now been one of the driving partners in OpenXR. And now eye tracking is actually, gaze tracking is standardized in OpenXR as well. So we think that eye tracking will be a commodity signal or way of using your device. So we're focusing on standardizing part that makes sense for everyone. And then you can have more exotic applications like part of the HP Omnicept is more special with a lot of different sensors. That will be further down the road. But we also have a complementary API set that you can get from our webpage, where we have integrated our eye trackers. But we don't want to drive to own the ecosystem when it comes to application. We think the existing bodies, the existing XR runtimes manufacturing are, and OpenXR is the future way to go. If we were to focus on research only, then we would just try to do it ourselves. But we are in favor of standardizing things, and then we do complementary solutions just to help and assist how to use eye tracking, which is there's some tricks you may want to know when you use eye tracking that we can help with.
Okay, that's really an interesting topic, because I was always thinking, if I make an app or some program that makes use of eye tracking, then how can I make sure that different headsets can use it, right? There's also other headsets, like the Pimax headset they're using from 7 Invent Sun, for example, an eye tracking module. So how would that all work together? But then you can simply program against OpenXR and you're good to go, which I think is great.
Yeah, I think that's the only way forward long term. We don't want to drive fragmentation. We want to drive unification. And at the end of the day, you will always use the game engines anyway. So let's ensure that the game engines are fed with a standardized kind of signals all the way, and eye tracking in one, but then the rest of the hand controllers as well. So I think that's super important.
Okay, that makes sense. So you also mentioned about the different kind of use cases, the 3 categories. Let's go more into category 1, like making better devices. And here especially, I think we're interested in dynamic foveated rendering. It seems so interesting. You look at something and only this area will be rendered at full resolution and the rest kind of is blurry, but you don't see it because your eyes are just made like this. That simply, you're not aware of that fact. And it works actually brilliantly. I've tried it here on the Pico Neo Eye. They have some kind of applications that work like this. And you can see a difference, which is incredible. And it makes a big difference as compared to fixed foveated rendering, where just the middle part is clear. And if you look at the side, you will see it, right? I think that was used in the Quest 1, probably also the Go, right? They had it, the fixed foveated rendering. But dynamic foveated rendering is really something special. Now, what I'm thinking, could it be implemented on some kind of deep driver level, where where not every game developer has to implement it with themselves in their game, or how would that work actually?
Yeah, I mean, that's where the whole drive is going. We're not there yet, but I'm pretty confident that we will get there. I think, for example, NVIDIA's VRS were lowering the bar, doing foveated rendering. It was certainly possible before, but it required a lot of work, a lot of heavy lifting. With VRS, it's much less. It's almost a recompile. Same with Qualcomm's Adreno foveation. It's also very, very low touch. On some game engines, you basically only need to do recompilation. So the whole move is going towards moving it down to the driver level. it will be there. I can't say more right now.
Okay, well, you know something. Okay,
but
it's gonna
I
happen.
think it's for sure. I mean, it's obvious that it needs to go there, and actually the static foveation, I really like that
Okay.
because that's a prelude to that. From our perspective, you have to have eye tracking because as the headsets gets better, your image gets better. You have clear vision in your periphery in future headsets. So having that kind of tunnel down into just having the central part in high resolution doesn't make sense at all. But since you are tunneling down today, you have the infrastructure to just move that tunnel around. You only need to add eye tracking. And that goes for transport as well. When you have over USB cable, you also there have static foveation for the transmission of the actual image if you're doing host or cloud computing. That you could use adding eye tracking to as well. So I think your observation is absolutely crystal, but as headset gets better, you actually want it to be clear all over, and eye tracking enables that.
Okay, that's really cool. Then one more thing that I'm really interested in is what you said about the content being rendered in the cloud, right? This is like a future technology. It's already there, right? From NVIDIA, called CloudXR. The thing is basically here. What we're waiting for is the 5G networks to make it happen, like all over the world. And I would like to ask you that you just said something really interesting. I wasn't even aware of this. So what I'm really interested in is CloudXR, the NVIDIA technology. So rendering things in the cloud, like the content for your XR headsets of the future. Like, for example, you could have your Steam VR games rendered on an edge server in the cloud, and then this is being sent to the user via 5G network into the headset itself. That's something that I really hope is going to happen, and that's probably sometime in the future. And what I thought is very interesting, and I was totally not aware of this, that actually, you can send the gaze information to the cloud, and then just this part is rendered that you need, right? And then you save lots of data, which will make the whole thing even better over a streaming connection. I think that's super exciting. And what do you believe? Is this technology already like built into CloudXR, or are you working on this together with NVIDIA? And first of all, these two questions.
Yeah, and I can't do. I mean, who we work with in detail, it's. I mean, we know NVIDIA extremely well, but just to your vision, I 100% agree and honor that. I think since you were referring to the static part, you because you do need to limit your processing. And you're doing that, and you also need to limit the transfer. So adding eye tracking, as long as the latency is short enough, is what we are great believers on. And it doesn't necessarily have to be to your Pico Neo 2i standalone headset. It could be to Omnicept as well. If you run it on a very light laptop, for example, you don't necessarily need to have a huge 380 GTX graphic card to run your headset. Maybe you can render it in an enterprise system. It doesn't necessarily need to be 5G metro system. It can be a corporate 5G system. So, or it can even be on a regular Ethernet LAN. So I think the whole concept of having off the device or off the PC rendering, I think that's where everything is going. And it's not. And if we can make that more cost efficient and make that more better useful of resources, we can. And that's why that's one of the big drivers, I think, for eye tracking. So the device specific parts are there. I mean, we even have AR displays that doesn't even work unless you know where you're looking.
Okay.
So for us, eye tracking is absolutely fundamental to future XR technology. And of course, I'm from an eye tracking company.
But it makes sense, yeah. It does make
And I like your static foveation. I just love that part.
Right. But even though I'm not in this industry, but it makes sense what you're saying. It makes so much sense. And you also mentioned my interview with HTC last time, and they also talked about the all-in-2 devices, those XR viewers that are probably connected to your phone, and your phone also just has this limited processing power, and then probably also it will make so much sense to only render a certain part.
Yeah,
Cool.
and for us, if you look on the HP, for example,
Right.
we think those better devices portion is the gateway to ultimately consumer headset as well. Because if you want to develop a gaming application, you want to have a deployed installed base of hardware that supports it. So if you have foveated rendering or foveation technology that works for every application, then you have a reason to put eye tracking into all devices. And when you have that, there's a big reason to develop not only for enterprises, which has value, including buying the device itself, but also for actually doing a proper game development with eye tracking. Because once you have the devices, there's the next layer. How much you can do with eye tracking in games is just there's no limit. It's just I mentioned a few, but just having your we made an implementation in PC, which I thought is fun, in a zombie game, and when you look at the zombie, it detects that it's like burning inside the head of the zombie, so it starts to look and attack you. So you can it's kind of, you can use the reverse. If I have the attention, then the monsters jump you. So there's a lot of kind of fun part that you can do with eye tracking that is not necessarily obvious.
Okay.
Or that if you look on the sun, well, it darkens or it lightens your screen and so forth. So there's a lot of subtle effects that doesn't have to do with you doing some kind of action.
Right, lots of potential there. So now, since I'm talking with a real insider in the industry, I would like to ask you, like, this vision that our XR content is being rendered on the cloud and sent to us via 5G. What do you think? How far is it away from reaching the mass market, like in a Quest 3 or 4? When will the stuff be rendered and sent to us? What do you think? How many years?
In the Quest 3 or 4.
All right. Okay.
No, I don't. But I think like any big trends, it often takes a little bit longer for penetration. But when it comes, it's much more massive.
Okay.
So I think maybe we will start seeing kind of attempt next year.
Wow, next year. Okay.
Just the attempt,
Okay.
yeah.
Will it work well?
And then we will see maybe deployment in 3 to 4 years,
Okay.
kind of in mass adoption.
Mm-hmm.
But who knows? I mean,
All right.
it depends on. But I think there's so many things speaking for that kind of setup, and it's not only XR. It's for everything or most.
Right.
The good old thin clients, if you remember them in the 90s,
Yes.
that's what's happening now.
Okay.
And it took a while, but it's right now it's massive.
All right. Got it.
So it will come, I'm 100% sure, but timing-wise, who knows?
Mm-hmm. Okay, cool. So let's talk about the other part of eye tracking where you could analyze and find out more about the user. And I think that's really interesting in the Omnicept because one of the use cases that HP told us about was, I think it was some kind of like flight simulator, and you could find out about the mental state of the person who's in the flight simulator. Could you tell us a bit more how this would work?
Yeah, no. So HP, they've kind of put eye tracking into their headset and a couple of other sensors, and then they use artificial intelligence to kind of, based on a numerous number of people, decide, okay, based on how they flicker with their eyes, how their pupil are dilating, how their heart rate is changing. Okay. They can decide, okay, what kind of level of cognitive load does this person have? So in that case, it's sensor fusion, which of course is how you do it, because as a human you have different sensors as well. So that is super exciting, and that's a very good in all kind of training and simulation applications, whether it's pilots, if it's having a speech like Ovation, or if it's drivers, or if it's basically research. Well, we think that's super interesting, and I think he has done a great job kind of bringing this to an audience that is beyond the researchers. Now it's available for every enterprise to use and to find good applications using these features.
Okay, that makes sense. So having all this data about your eyes and your gaze, where you're looking at, of course, we'll also have to think about like privacy issues, right? And well, like looking at where you look at, that is basically, yeah, well, it's really important, and there's lots of data that can be caught from that. And how would you deal with these kind of issues, with privacy issues?
I mean, we have a privacy policy that we have stated on everything we do, where if you store the data from your eyes, or if you transfer the data from your own headset or host computer elsewhere, you need to notify the user what you're doing, and need to get a consent from the user. And this is something that we have implemented in all our applications, since we also have devices for professional and for assistive use. When we are doing that, we inform the user, and we can find the policy on our webpage. We also, when we sell Tobii eye trackers to OEMs, we require them to honor the data transparency policy of ours. So they are, in their development terms, stating that if you're storing or transferring eye tracking data, you need to inform the user. So that is, and I think this is an extremely important topic, because since eye tracking is so powerful, if you misuse that trust to the user and collect data from the user without the user's knowledge, then it can backfire the whole part of eye tracking. And then we have at Tobii also separated the gaze signal that you use for interaction or for insights to the one that you use for foveation purposes. We call that spotlight technology. So that signal is slightly different, but it can also take a route through the system that is not accessible for applications. Maybe it's like driving directly to the driver, not having access to that. So even though you're not using eye tracking, you know that you're protected. So this is something that we have had absolutely zero problems communicating or getting acceptance from the OEMs. They immediately think, "Oh, that's great. We will." And I think if you, for example, look at Microsoft's implementation in your desktop of eye tracking, they also explicitly state we don't store or transfer the data. So they never collect that data. So it's a very, very important topic, and we think that we will see more of that, and we hope to get some kind of industry collaboration around that eventually. We're trying to get that going. But as far as our eye tracker concerned, that's our firm requirement.
Oh, that's great. So good to know. You only sell your eye tracking to companies who will agree to that these companies, whenever the user uses the headset, they will be informed if the eye tracking data gets stored and probably analyzed in the future, right? That's really good.
Yeah.
Right. The question also, of course, is like when that OEM has to have this kind of requirement, at what point in time will they ask the user that? Because very often we get the devices and then, you have to accept the terms and conditions, right? And actually nobody reads them, and probably you also don't do it. and then probably you did agree to it, and then, it's a problem, right?
Yeah, no, but I think from our perspective, we can do what we can.
Yeah.
We can't limit the OEMs to what they want their users to do with the eye trackers, but I think we can work with the OEMs and the VR providers to have a joint view on this, and I'm sure that will be the case eventually. We're not quite there yet, but
Okay.
just looking at Microsoft works as one example, they're extremely keen on this, and I know that Valve also have a very, very high data privacy policies in general. So I would just see that it's in the starting phase. We have it in the terms of the developers, and it will absolutely be regulated.
Okay, I think that's really a must and something very important. And I believe that being aware of the power of eye tracking, and also like through a show like this, the people will be just more aware what it can do, and that we should look at these kind of privacy concerns that might come with this kind of technology. And yeah, it's good that you have this and that you're aware of this and that you are like thinking into it, like how to make sure that this is not being misused, and like that lots of trust would get lost, right? If a big player would misuse that in some way or another, probably people will not be so relaxed anymore to wear a cool headset, even though it's cheap, right? Or something like this. So
no, exactly. And so it's you need to kind of treat trust in a trustful way, and because as you say, it's so powerful. So in both for fun and for insights.
Right. Wow. Super interesting. And I believe that we have learned so much now about eye tracking, getting to the end of this interview. And I think at this moment in time, we understand that how powerful this is, and that it is going to be in, I think, most probably in all of our future headsets, because it makes so much sense. And I think your job is very secure.
It's at least fun.
yeah, right. That is so great. Yeah, Johan, I simply would like to thank you for your time to give us an insight into Tobii, into what you do, and into the technology in itself, because I believe people were aware of eye tracking, but they didn't really have like a real good idea how it works and what it can do. So thank you for giving us this insight.
Thank you for having me, Sebastian, and everyone who wants to reach out to us, just contact us on the webpage.
Okay, I'm going to put the contact data of you, or that you want people to contact, down into the description of this video. Thank you so much, Johan, and talk to you next time.
You too.
Bye. I believe that now we have a much better understanding of eye tracking, how it works, and how it's important for the future of XR. So thanks a lot to Johan Hellquist for this interview. I really hope that you enjoyed it and that you found it informative. If yes, give it a thumbs up. That's important for the algorithm as well. And of course, if you have not yet subscribed to MRTV, then absolutely do that now. And I'm looking forward to see you in the next episode.